Hello guys, we are now on the part 2 of operations on radicals, focusing on multiplying and dividing radicals. Let us begin with multiplying and dividing radicals with the same indexes. Let us remind ourselves of the product rule, which simply means that the radical of a product is equal to the product of the radicals of each factor. All right, so example number 1, 2 square root of 18 times 5 square root of 2. So what we're going to do here is we're just going to multiply the coefficients or the front of the radical, which is 2 times 5. That's going to be a 10. And you will just multiply square root of 18 with square root of 2, which is square root of 36. So the answer is, all right. And now to further simplify, we're now going to extract the square root of 36, which is a 6. So that will be a 10 times 6, which is 60. Let us now go to example number 2. 2 square root of 3x times 3x square root of 8x cubed. So just once again, multiply the coefficients and the coefficients. So the number in the front with this one is 6x, and multiply the number inside the radical with the number inside the radical. So that's going to be 24x to the fourth power. All right, now, since this is inside the radical, we will have to extract the prime factors and also expand this in order to form groups of 2 because your index here is a 2. Make sure to circle the 3 because that's a prime number, and then extract the prime factors of 8. Circle the prime factor of 2 and extract the factors of 8. Prime factors of 4, I mean. All right, so after doing that, we're going to now copy this down and you will expand this and put all these prime numbers in place of 24. All right, now it's going to be 2 times 2 times 2 times 3, and then x to the fourth is x times x times x times x. What we're going to do now is we're going to look for pairs. Okay, so all these pairs are perfect squares and will go out. Those with no pairs will stay inside the radical sign. All right, so let's examine this. So this two right here that are in pairs are perfect square. They will go out, and that's this. I copy down the 6x, and this 2x's are from here. So this is for this one, and this one is for this perfect square right here. The 6 is the 2 times the 3, which 2 times 3, which has no perfect square. And so we will just simplify all these. All right, so for this 2 being multiplied, our final answer is 12x cubed square root of 6. All right, so example number 3. Cube root of 5 times cube root of 50. The answer is cube root of 250, and we got that by multiplying 5 times 50. Let us now simplify this by extracting the prime factors of 250. I want to start the extraction by doing 10 times 25, and 10 has factors of 2 times 5, which are both primes, so circle them, and extract the factors of 25, which are 5 times 5 and are both primes, so circle them. Then we write them all inside the radicals. And once again, because the index is a 3, we're looking for groups of 3, which is this is a perfect cube root. And so the 5 times 5 times 5 will go out of the radical sign and turns into a 5. The 2 will stay inside the radical sign because it is not a perfect cube root. So therefore, your final answer here is 5 cube root of 2. Okay, now flip the page of your notebook and go to the next page. We're now going to discuss about dividing radicals. Let's remind ourselves of the quotient rule, which is shown here. And this simply means that the radical of the quotient is equal to the quotient of the radicals of the numerator and the denominator, for as long as your a is greater than or equal to 0 and your b is greater than 0. All right, so for example number 1, 15 square root of 12 over 5 square root of 3. All right, so 15 over 5 is a 3. Square root of 12 divided by square root of 3 is square root of 4, which is going to be 3 times 2 because square root of 4 is a 2, and so the final answer is a 6. Example number 2, 2 square root of 10 over square root of 20. So let us begin. All right. So if we operate on these radicals, it's going to be 1. So 10 over 20. So square root of 10 over square root of 20 is going to be square root of 2 here at the bottom, and the 2 goes on top. All right. So what you have to understand is that the radical in the denominator is not permitted. So that is not considered as simplest form. And so that needs to be removed. So in order for us to remove the radical in the denominator, we will have to multiply this by 1 in the form of square root of 2 over square root of 2. All right. So let us begin with the denominator because that's our purpose. We need to be able to change this into a not a radical anymore. Okay. So now we're going to multiply this by square root of 2. The reason why we're doing that is because when we multiply square root of 2 times square root of 2, that becomes square root of 4. And square root of 4 is a perfect square of 2. So there's no more radical the moment you do that. Now, whatever you do below, you have to do on top in order to balance the expression. So your numerator is going to be 2 square root of 2 because 2 times square root of 2 is 2 square root of 2, and your denominator is going to be square root of 4. And the moment this happens, that becomes now a whole number because square root of 4 is really just a 2. All right, so this is now our answer that is permitted. However, if you look at 2 over 2 right here, we can still cross this out and it cancels out to become a 1. So therefore, if we do that, your final answer here just becomes square root of 2. All right, for our third and final example, we're going to work on 6 cube root of 4 over 18 cube root of 8. So let us begin. So what's going to happen here is we're going to simplify this coefficients, and 6 over 18 is 1/3. All right. So now that 1/3 is for the 6 over 18, and we're going to take a look at the cube root of 4 over cube root of 8. So by the quotient rule, we are going to just go ahead and simplify that by putting, so that is going to also be a 1 over cube root of 2. All right. I'm making this detailed because I don't want you to get confused. So the 1/3 is for the 6 over 18, and the 1 over cube root of 2 is for the cube root of 4 over cube root of 8. And now we're going to solve this and simplify. All right, so far we have 1 over 3 times cube root of 2. Okay, so I already told you that the radical on the denominator is not permitted. That's not considered as simplified. And so this has to go. I want you to focus your attention onto the index, and the index is a 3. Therefore, we have to create 3 pieces of 2 in order for us, 3 sets, 3 elements of 2, 3 factors of 2, in order for us to say that it's a perfect cube root. And the way to do that is this. All right. So notice that I didn't mind the 3 in the front because that's already a whole number. So that's not our this is not our problem. This is our problem right here at the bottom. So again, the index is a 3. The only way that I can create 3 factors of 2 is here if I multiply it by cube root of 2 squared. Now, because the moment I do that, then I will have 3 pieces of 2. That's the first one. And then now 2 times 2 here will create 3 sets. And so therefore, the moment I do this, it becomes a perfect cube root, which I can take out of the radical sign. And so when that happens, my denominator has no more radical. So let us go ahead and see what happens here. Whatever I do below, I do on top. So I also multiply the top by cube root of 2 squared. So now my numerator is going to become cube root of 4. And I'm going to multiply the 3 with the 1 here in the front. So 3 times 1 is a 3. And so now that will be a cube root of, let's see, 2 times 2 times 2. So this is a 4. So 4 times 2 is an 8. So that would be cube root of 8. All right, so let me explain this. Again, my numerator is that, and my denominator is 3. I just copied it down. And the cube root of 8 is a perfect root of 2. And let me explain why. Let's go ahead and get the prime factors of 8. Therefore, the cube root of 8 is equal to the cube root of 2 times 2 times 2, which in this case, because the index is a 3, you're looking for 3 sets right there. That is considered a perfect square and will go out of the radical sign. And that explains why the cube root of 8 is a 2 right here. We're not yet done. We're going to go ahead and multiply 3 times 2. So our final answer is cube root of 4 all over 6. So that concludes our lecture on operations on radical, focusing on multiplying and dividing radicals. I hope that you have learned a lot today.